Okay, so pay attention. This is f of x, g of x, h of x. Okay, so find the equation for these two functions added together. So the notation might look like that in a question or like that. Okay? So you might see either one of those. You'll probably see the second version more. Okay, so when we write the new equation, so the function f of x plus the function g of x. Okay, on your test I've asked you to simplify your answers. So if I ask you to simplify this, that means I could combine stuff like that. And we better title the equation something. So in this case, I don't have any, I might say find, if I had said something like this, find j of x, you know what I mean? I might ask you something like that, then make sure you put j of x here. So just make sure you're paying attention to what I'm labeling on a test. Okay, order doesn't matter when you add. When you subtract two functions, please make sure you're subtracting them in the proper order, right? Because subtraction changes. 5 subtract 4 is different than 4 subtract 5. So we have to do the h function minus the f function. And do you see that I put that in brackets? Because if somebody wrote this, if somebody wrote it like that, which would be a common thing to do you understand how that's creating a mistake on that term? Right? Okay, so if I have to subtract that whole function, then it looks like that, because the subtraction has to go on everything. And then we always need to title the equation something with an equal sign. Okay, so I'm going to go negative x squared first. X's can go together. Okay, next question is to multiply. So this one, order doesn't matter when you multiply, right? So the f function times the g function okay, so I'm going to FOIL this. So that's how I would have to multiply through that to simplify it. So x cubed plus 7x squared plus 3x squared plus 21x. Okay, when I'm on my test, I always have to make sure my final answer has some kind of equation title. And then I always have to make sure I simplify where I can. So on this, I can put those terms together. Okay, next question. There's our two equations. Find and graph g of f of x. So this is a composite function. Okay, so it means we're going to use the g function So what is the g function? The g function says x squared, but instead of x, I'm going to think about it as whatever x is the input squared. And the f function is going to go into the input spot. So you're putting the f function into the g function. Okay, so if I put the f function in there, it would go like that, and if I wanted to simplify it, that would cancel. Okay, let's talk about the domain of this. Okay, what's the restrictions on this domain? Can you think about when you square root numbers, what can't you have there? You can't square root negatives, right? So what's the lowest x value that's good? What's the lowest x value you can have before it becomes negative? What's the lowest number that you would be able to plug in? 1? Because now if you plug in 0, 0 subtract 1, now you're negative, so that's not good. And anything bigger would work, right? So when we look at this, okay, we have to consider that when we were inputting this function in there, we have to consider the domain being restricted already, okay? This is a squared, which is a parabola. What do you know about their domains? They're not restricted, right? We're good with that. Okay, how would I graph this? Let's talk about graphing something like this. How would I graph? Anybody know what shape this makes? From all your past experience of graphing, what shape is that? It's a line. What do you know? 2 things about that line that you would know. -1 is what? What would -1 be on that graph? Y-intercept. And when you graph lines, you talk about slopes. What is the slope of that? One, because 1x. On a line, what do you do when you move slopes? What kind of pattern do you move in? Up 1, right 1, up 1, right 1. Gotta go all the way back to grade 10. Isn't that hard? Okay, so I'm just going to draw this lightly because I don't want these x values here. That's where I would kind of start. And I would move up 1, right 1, up 1, right 1. And that would be my line. But don't you remember this? Our domain. I can only start from the x value 1. So like I can't include that point and stuff. Okay? So it's the line, but it gets cut because of that domain. Okay. You know what I'm going to do for this last one? I'm going to give you a different example here. I'm going to give you a different example. Okay, ready? So we're going to do the division. So the new function, if we divide, so the f function gets divided by the g function. And what should we do with this? We're gonna difference of squares that. Okay, you ready for some flashbacks? Your rational functions. Let's talk about this. Non-permissible values. X is not allowed to be -2. X is not allowed to be +2. Those values are not allowed in the domain. Okay, so I already know my domain can't have those values. What do you know on the graph? What does this do? Do you remember? Because this would happen. So there would be a hole in the graph. And what would this be on the graph? Vertical asymptote. And what do you know about the rules if the degree is higher on the bottom? What's going on with our horizontal stuff? Then you have a y = 0, right? If the bottom is bigger. Okay, can you figure out the actual coordinate of the hole? So if I was to rewrite this with the canceled, if I cancel that, it would look like that. So what is the coordinate of the hole? So can you plug a -2 into that? What do you get when you plug a -2 in? Are you getting -1/4? Okay, so now we're going to write a domain and we're going to write a range. Okay, so when we talked about our domain, what are the values of x that we had to skip over? 2 and -2, right? We didn't like those x values. So I'm going to show you two ways you can write this. So you could go -∞ to -2. Make a skip, -2, and then once you get to 2, you have to skip, and 2 to infinity. So that's showing me every time you hit a -2 you skipped, a 2 you skipped. Or you could write it like this. Something like this would show me x could be any real number except x cannot be those numbers. Okay, range. What kind of y values did I not want to be at? Well, here I had an asymptote, so I didn't want the y value of 0. And remember that we had a hole. So if I skipped over that hole, I skipped negative a quarter. Okay, so I can show you the two ways to write it. So negative infinity to negative a quarter. Skipped it. Then we went from negative a quarter to 0. We skipped that whole. And then 0 to infinity. So that's showing you you're skipping at negative a quarter and you're skipping at 0. Or you could write y can be any real number except 0 or negative a quarter. I'm okay if you write either way, whatever makes sense to your brain. Okay, so when you're doing this stuff, you're probably going to run into topics with rationals. So please remember the rules. You got wholes, asymptotes on rationals, okay? And radicals. Just to recap with radicals here, what do you know about this radical? Where does it start? Give me the starting point, location. Which coordinate do you start from? Positive 2, positive 5? And it goes that way? Okay, so remember the transformations, because I'm going to probably ask for some domains and ranges. Okay? Also remember radicals. What's wrong with a radical that looks like this if I want to do a transformation on it? My transformation should be right 2. Okay, so remember that. And then obviously radicals, I'm not sure if you run into this, but do you remember the negatives? Which way flips? So if your negative is in the front, what does it do? Then it goes that. And if your negative is on the inside, then it goes like that, right? The domain switches. Here are the range switches, here's the domain switching. Okay, so you're going to run into a lot of background information while you're doing this.